Well, welcome back. We are going to continue in our study of ratio and proportion, talking about proportional and non-proportional relationships today. And a proportional relationship has to do with quantities that have a constant ratio. So non-proportional relationships do not have a constant ratio. And our objective is to be able to identify which relationships are proportional or non-proportional. So here's an example. Uptown Pizzeria sells medium pizzas for $7 each, but they charge a $3 delivery fee for every order. So we want to know, is the cost of an order proportional to the number of pizzas ordered? So we need to do a little bit of analysis here. So if we order one pizza, what does it cost us to order the one pizza and have it delivered? We're assuming all of these are delivered. So one pizza would cost us $7 for the pizza plus the $3 delivery fee, which would be 10 bucks. Okay? Two pizzas would cost us $14 plus the $3 delivery fee, which is 17. And likewise, 3 pizzas is 24, 4 pizzas is 31. So the cost per pizza, if we take the total cost, $10 for one pizza, we get 10 bucks per pizza. 17 divided by 2 brings us down to $8.50 per pizza. 24 divided by 3 gives us $8 per pizza. And 31 divided by 4 is $7.75 per pizza. So you can see that the cost decreases as we order more pizzas. That total cost per pizza is less because of the flat rate delivery charge. So did we get a constant rate here? The cost per pizza, was that the same? No, it was not. So therefore, this is a non-proportional relationship. Here's another example. We have a recipe over on the right for some fruit punch. It takes a half a cup of sugar, 1 envelope of mix, and 2 quarts of water. So if we use that recipe, we want to determine whether the amount of mix that we use is proportional to the amount of sugar used. Well, let's take a look. If we use 1 envelope of mix, how much sugar does that use? That uses 1/2 cup of sugar. 2 envelopes is 1 cup, 3 envelopes is a cup and a half, 4 envelopes is 2 cups. So we'll go ahead and fill in the water here. I'll do that as we do part 2. That's for part 2, so I'm going to leave that blank for right now. So the number of cups of sugar divided by the envelopes of mix. We're going to take 1/2 and divide it by 1, and we're going to get 1/2. Okay? 1 divided by 2 gives us 1/2. 1.5 divided by 3 still gives us 1/2. 2 divided by 4 gives us 1/2. So the question is the amount of mix used proportional to the amount of sugar used? And the answer is yes, it is. Okay? How about the second part of this question? Is the amount of sugar used proportional to the amount of water used? So we already have the amount of sugar in the first column. The amount of water is right here. So if we use a half a cup of sugar, we need 2 quarts of water, right? So there's 2 quarts. And when we use 1 cup of sugar, then we need 4 quarts of water. When we use 1.5 cups of sugar, we need 6 cups of sugar or cups of water. And with 2 cups of sugar, we need 8 cups of water. So now what we're going to do is we're going to take the number of cups of water down here, is the amount of sugar used proportional to the amount of water. We're going to take the amount of water divided by the amount of sugar. So the water was 2 divided by a half gives us 4. 4 divided by 1 gives us 4. 6 divided by 1.5 gives us 4. And 8 divided by 2 gives us 4. So is that one proportional? Did we also have a proportional relationship there? And yes, indeed, that is also a proportional relationship. The beginning of the school year, Isabel has $120 in the bank. Each week she deposits another $20. Is her account balance proportional to the number of weeks since she started school? Well, here's week 1, 2, 3, and 4. Here's her beginning balance. So in week 1, she's going to add $20 to that, so her ending balance will be 120 plus 20, right? So now week number 2, her beginning balance is 140, right? Oops, let's see if we've got that in here. Whoops, I don't think I have that in there. So her ending balance will be 120 plus 20 times 2, or 160. Okay, I'm going to go ahead and write her beginning balance in here. I thought I had that in here. So her beginning balance here will be 140, right? and she's going to add another 20 to that, so that'll give us 160. Her beginning balance here will be 160. So then if we add another $20 to that, she'll get 180. Her beginning balance for week 4 is 180, right? And we're going to add $20 to that, and that gives us 200. So her ending balance is given here. So if we take her ending balance divided by the week number, will we get a constant rate? Well, let's check it out. 140 divided by 1 is 140. 160 divided by 2 is 80. 180 divided by 3 is only 60. And 200 divided by 4 is 50. So is her account balance proportional to the number of weeks since she started school? And the answer is no. We did not get a constant rate. It is not proportional. So determining whether or not a relationship is proportional, you have to divide those two quantities and get a consistent or constant rate across every single one of those columns. Here's a chance for you to check your understanding. I've created 3 problems for you. Go ahead and set up a table. So when it says create a table right here, I want you to actually do that. Actually create the table. Let me underline that to make sure. Create a table. So when you bring these to class, you should have a table for each one of these problems. You cannot possibly tell this without creating a table, so I want to see your work on these. So you're going to come to class with 3 different tables for these and show me your work to determine whether or not these are proportional relationships. See you next time.